Hello and welcome to our project proposal for dust storm frequency in Iran. Thank you for trusting our GIS team to help you answer the question of where to focus your mining efforts to minimize losses in relation to sand and dust storms across arid and semi-arid regions of Iran. A 2019 investigation by the World Bank found that throughout the globe, sand or dust storms account for welfare losses totaling $3.6 trillion and over 2.5% of gross domestic product. In this project proposal, we will present a visual GIS work plan detailing the various geospatial analysis techniques which will help to determine locations in Iran that are least likely to be impacted by sand and dust storms based on current climate model projections. Our GIS work plan can be broken down into two major steps: producing the land cover map and discovering how dust storm frequency is expected to change based on future climate projections. To produce our land cover map, we're going to clone our ArcGIS Pro environment, install Google Earth Engine dependencies, compile some Python code using Jupyter notebooks, and then export the Iranian land cover dataset. Next, when we investigate how dust storm frequency is expected to change based on future climate projections, we will begin by downloading Iranian shapefiles and climate data statistics. And that will be for step 1. Next, we will join the climate data to the city's point file and intersect the cities with the admin polygon layer. Then we will execute a select by attributes based on the climate parameters and extract the information to a new layer. Then the selected polygons are clipped from the admin boundaries layer and symbolized in red, yellow, green, red showing increase in dust storm frequency, yellow showing no statistical significance, and green, a decrease in dust storm frequency is expected. Finally, we will add the land cover dataset to the project. Next, we'll interpret the results that the different climate parameters have on dust storm frequency. Climate scientists have identified 5 major climate parameters that largely influence sand and dust storms in Iran. To identify the most suitable locations for mining operations, our team of geospatial analysts has conducted a preliminary analysis of 18 arid and semi-arid regions in Iran, using spatial analysis to determine the impacts of 5 major climatic parameters on sand and dust storms. Next, we'll look at the impact that rainfall has on dust storm frequency. In general, rainfall and dust storm frequency have an inverse relationship, with an increase in rainfall leading to a decrease in dust storm frequency. However, this relationship is not consistent across all locations. In some places, an increase in rainfall is projected to lead to an increase in dust storm frequency. Next, we'll look at average temperature. The relationship between dust storm frequency and average temperature varies depending on location and other factors such as proximity to dust source regions. In some locations, a decrease in temperature is expected to increase dust storm frequency, while in other locations, such as the one with the largest increase in average temperature, there is no projected change in dust storm frequency. Overall, the relationship between these two variables is not statistically significant. Next, we'll look at maximum temperature. Despite our initial investigation being unable to determine a statistically significant relationship between dust storm frequency and maximum temperature, it is well understood in the climate community that differential heating of the Earth's surface is the driving force behind wind dynamics. We believe that future research into this topic will yield helpful discoveries about the relationship between maximum temperature and dust storm frequency. Next, we'll look at the relationship between average wind speed and dust storm frequency. Dust storm frequency and average wind speed have a positive correlation. It suggests that there is a direct relationship between the average wind speed and the frequency of dust storms. As average wind speed increases, the frequency of dust storms is expected to increase. Next, we'll look at maximum wind speed in relation to dust storm frequency. Dust storm frequency and maximum wind speed have a positive causal relationship, meaning where maximum wind speed is projected to increase, dust storm frequency will increase as well. In conclusion, there were two major processes in our analysis. First, by leveraging Google Earth Engine's cloud computing and artificial intelligence machine learning analysis of Sentinel-1 and 2 imagery, our team has demonstrated the capability of generating a high-fidelity land cover dataset for Iran. Second, our team of scientists and geospatial analysts were able to analyze 18 locations in arid and semi-arid regions of Iran to forecast how 5 climate parameters, rainfall, average temperature, average wind, and max wind speed would influence sand and dust storms in Iran. Thank you for your time. Have a good day. We look forward to working with you in the future.